Hi everyone, and welcome to the tutorial where we will learn today on setting up a Apache Hadoop cluster. Although there are various distributions of Hadoop as we have already discussed, and you could set up a Apache Hadoop cluster, which is the core distribution. You could be setting up a Cloudera distribution of Hadoop or even a Hortonworks. However, for Cloudera, you would need machines which are really powerful, at least machines which have 16 GB of RAM, and in which you can set up multiple virtual machines, each virtual machine of at least 4 to 5 GB. Same thing applies for Hortonworks, or you could always download and set up a Cloudera Quick Start VM or a Hortonworks sandbox. In this session, we will learn how to set up Apache Hadoop cluster, which is the core distribution. And if one has learned how to set up Apache Hadoop cluster, then they would understand the internals of setting up a cluster, different configuration properties which are needed for your cluster setup. Now for this, we need to set up multiple machines as you see on my screen, and for this you will have to download the Linux disk image. So we are using Ubuntu for our cluster setup. You can always go to Google and type in Ubuntu disk image ISO file, and you could search for this, and that should show you a link like this which says Ubuntu 16.04. You can click on this link, and depending on your machine, so my machine is a 64-bit machine, and so I would download this disk image which is already downloaded on my machine. And if your machine is a 32-bit machine, then you can download this one, which is 32-bit PC i386. Now to set up a Apache cluster, you could even do it with a machine which has 4 GB RAM, and you could easily set up at least 2 virtual machines which can then be used to set up your cluster. Now this also needs you to download a virtualization software. So you can type in download Oracle VMbox. It is pretty lighter on the machine. You can search for the link. You can easily say wiki, and that should show you download Oracle VMbox. Now I would suggest going for a older version rather than going for the latest version, probably because that might have some more patches to be installed, and you can click on an older version of Virtualbox, and then based on the machine which you have, download the relevant Virtualbox version. Once you have downloaded Oracle VMbox and once you have downloaded the Linux disk image, you are ready to set up machines within your virtualization software, which can then be used to set up a cluster. To set up a machine, click on New, and here we can give a name. So let me give M1. I will choose Linux, and I will choose Ubuntu 64-bit. Now in certain cases people might have problem in not being able to list down Ubuntu 64-bit, and that basically means that you have to enable virtualization in your BIOS settings. So restart your machine, get into BIOS, enable your virtualization, and then you should be able to see 64-bit option here. In any case, and later, if you face issues with the Oracle VMbox, you can also go for VMware Workstation. Click on Next, and this tells you that you would want to allocate RAM. So we can go for now with 1.5 GB. Depending on your machine, you can even give more RAM to your every individual machine within your virtualization software. So I'll choose 1.5 GB, click on Next. Now here it says create a virtual hard disk, or do you want to add a virtual hard disk? So we'll say create a virtual hard disk now. Click on create, and then you can choose VMDK, that is virtual machine disk, which will also allow you to use the same disk image in case you would want to use a different virtualization software. Click on next, and then it says how do you want your hard disk to be allocated. So let's go for dynamically allocated hard disk. That is, as you store data on your disk, it will be using your parent disk storage. Click on next, and here we can give the size of our disk. So I'll keep it 20 GB. That's more than enough for machines which will be hosting my Apache Hadoop cluster. Click on create, and we have given the basic settings for my machine. However, this does not have any disk assigned to it. So now while this is highlighted, click on settings and then click on system. Here we can increase or decrease the RAM. We can even give more CPU to our machine, that is CPU cores. You can click on storage, and here where it says empty, click on this, and from the drop down select your disk image which you would have already downloaded. Now let's click on network, and to have my Hadoop cluster set up, I would need every machine to have a different IP. Now I could go for NAT, which is network address translator, but then every machine would have the same IP address. So it's good to go for bridge adapter, and if you are using your own personal network, every machine setup will receive a different IP address. Click on OK, and you have given all the settings for this machine. Now you can click on start, and this will start your machine. It will recognize the disk image which you have added, and basically this should allow you to give settings to set up your first Ubuntu machine. Let's just wait for a couple of seconds, and that should give me an option which says either try Ubuntu or install Ubuntu, and we will go ahead with installation of Ubuntu distribution of Linux for our machine. Now while this comes up, I can always set up one more machine quickly by clicking on new, giving a different name, choosing Linux, click on next. Let's give some RAM, click on next. Create a virtual hard disk now, click on create, choose VMDK, click on next. Dynamically allocated hard disk, click on next, give the size of your hard disk, and then click on create. Once this is done, repeat the steps, click on settings, system, processor, let's give it 2 CPU cores, storage, click on empty, and then let's choose the disk image, and in network I will choose bridge adapter. Once this is done, click on OK, and just do a start of your second machine also. So we can parallelly set up two machines, which might approximately take 5 to 10 minutes. And once your machines are up, we can then go ahead installing some relevant packages and Hadoop to set up our Hadoop cluster. Now let's look at our M1 machine, and that's slowly coming up using my disk image. And once it comes up, I should be able to install Ubuntu in M1. So here is my machine, which is slowly coming up. And let's look at the second machine, if that is also coming up. So click on machine 1 here, and it says the connection is established. So it is using the bridge adapter which we have chosen, and then it should throw me the options which allow me to go ahead with installation options. Here we can click on install Ubuntu. It says download updates while installing Ubuntu. It's good to select this. Click on continue. It says erase disk and install Ubuntu, and we are good to do that because it's not erasing anything from my parent disk. It is doing this for this particular machine. So click on install now. It says if you continue, the changes listed below will be written to the disk. We are fine with that. Click on continue. And now let's choose the time zone. So in my case it shows Berlin. In your case it might show the city or the country where you are in. So click on continue, and don't worry if it says it's disconnected from internet. We don't need internet as of now because we have already added the disk image. So the language selected is English US. Unless you would want to have it in a different language, click on continue, and it needs name. So let me give my name here. I'll say what would be my computer name. So I'll say M1. I'll give a username. So we need to have a common username across all the machines which would be used for Hadoop cluster. So pick a username and type in a name. I'm giving SDC. I'll give a simple password for my machines, and then click on continue. So all the relevant things are done for this machine, and then we will have to give it around 5 to 7 minutes while it sets up everything, and then finally I will get a pop-up message which says restart or reboot your machine, and my machine would be ready. The same things we'll do on my second machine. So I'll click on install Ubuntu. Then we can select download updates while installing. If it shows up and if it says that there is no internet connection, nothing to worry. We can always come back to this. So click on continue. Erase disk and install Ubuntu. So click on install now. Click on continue. Let's give a time zone here and click on continue. We can always change the time zone later also. Once this is done, you will have to give your machine a name and then also a user which you have already set up in machine 1. Now we would have a Hadoop cluster and we would also have HDFS which would use the file system from M1 and M2. Thus we need to have a common user which is set up in all the machines which you would use for your Hadoop cluster setup. So wait till it gives you different options and carefully select your machine name, your username, and give it a simple password. Click on continue, and here I'll give my name. I'll say this will be my machine 2. I'll say HDC as the user. I'll give a simple password and let's click on continue. Now we will have to wait for 5 to 7 minutes. My first machine is already being set up and my second machine will start now. Once both the machines are set up and once I get a message, please reboot your machine, we will have to wait. Both of my machines are almost about to be set up and they will give me an option to reboot. Now meanwhile, what you can also do is you can download the Cloudera Quick Start VM. So you can just type in download Cloudera Quick Start VM and you can search for the package. Now this can be used to set up a quick start VM which would be a single node Cloudera based cluster. So you can click on this link and then basically based on the platform which you would be choosing to install, such as using a VM box or which version of Cloudera you would install. So here I can select a platform, so I can choose Virtualbox and then you can click on get it now. So give your details and basically then it should allow you to download the quick start VM which would look something like this. And once you have the zip file which is downloaded, you can unzip it, which can then be used to set up a single node Cloudera cluster. So once you have downloaded the zip file, that would look and something like this. So you would have a quick start VirtualBox and then a VirtualBox disk. Now this can be used to set up a cluster. Ignore these files which are related to Amazon machines and you don't need to have that. So you would just have this and this can be used to set up a Cloudera cluster, which we can learn in further sessions. There is another option that you could just be setting up one machine and then your VM box has an option of cloning the machine where you can set up one machine with all the details like Java, Hadoop packages and other relevant packages, and then you can clone it, but then you will have to take care that both the machines should have different IP, which means once the machines are up and if you have cloned the machine, then you would have to manually change the IP address in the machines. So either you could go for this option or do it as I'm doing here, that is set up two machines individually. Now it would give you this message which says installation is complete. You need to restart the computer in order to use the new installation. Click on restart now and that should restart my M1, and similarly I get a message for M2, so I'll click on restart now and both my machines should restart. So click on M1 again and here it might say you have to remove the installation media, so we can click on enter and this should basically start my machine. Same thing applies to machine 2. So this will also say remove the installation media and we were just using a disk image, so we have to just hit on enter and that should basically bring up my machine. It will also be advisable that if your machine is low on RAM, you can set up one machine and then you can use SSH related utilities to copy the data from one machine to other machine. So let's click on machine 1 and let's go ahead and set this up. Now we will have to install some packages like wget, which allows you to download things from internet. We will have to download Hadoop package. We will also have to download Oracle JDK, which will be used. Although Apache works with OpenJDK, it is advisable that we go for Oracle JDK, and Ubuntu machines by default do not have Java installed. So we will have to download the Oracle JDK package, untar it, and then set up our Java. And these steps have to be repeated on both the machines so that my both machines can be used for a Cloudera cluster. So I'm waiting for my M1 machine to come up so that I can check its IP address, I can update its IP address and host name, and then I can start downloading the packages which will be needed for setting up a Hadoop cluster. So my machine 1 is up here. I can click in the password box and I can give in my simple password which I had set up for my machine 1 and hit on enter. So that should allow you to log in, and same thing applies to machine 2, which is still coming up. So let's go back to machine 1 and let's wait for its basic utilities and programs to come up so that we can start configuring our machine. Now remember, if you can configure your machine in the simple way and as smooth as possible, then setting up your cluster will become a cakewalk. So you can click on cancel if there are some issues like this. No need to worry about it. We are going for a simple Apache cluster on 2 nodes. So meanwhile, let me also log in to machine 2 by giving in my password and then hit on enter. Now, in both my machines, on the right corner, you might see the double arrow marks, which basically tells that your machine should be connected to internet and you should have no problem in downloading packages from internet. However, if you have some issues, then we will have to troubleshoot those and make sure that you can at least set up one machine which can also allow you to set up a Apache Hadoop pseudo distributed cluster, that is a single node cluster. However, to have the feel of a 2 node cluster or at least a 3 node cluster, it would be good to have 2 machines up and running, both connected to internet, both having Java, both have their IP addresses updated, and both having the Hadoop package downloaded. So now my machine 1 is up. It looks like it is connected to internet. From the right corner, I can click on this and then I can type in terminal and click on terminal. So this is my terminal and I'm already logged in as HDC user, which I had selected in the beginning. So let's start by typing in ifconfig, which gives me the IP address of machine. It is 0.116. And what I will do is I will log in as root by typing in sudo su and giving your password. You're logged in as root. Come back to the parent directory and then let's go to etc hosts, where I will update the IP address of this machine, which is 192.168.0.116. Here, let's get rid of this and let's say 192.168.0.116, and my host name of this machine is M1. So let's update this. Now I could get the IP address of my other machine also, so that I could basically make these machines ping each other. So let's do the same thing here. I will type in terminal and click on this, and let's quickly get the IP address of this machine, which should be a different IP address than my machine 1. So let's type in ifconfig and this says 0.217, which I will update here. So I will say 192.168.0.217, and that's my machine 2. And same thing, we'll do it in machine 2 also. So let's go to machine 2. Let's log in as root. Let's give the password and then let's go into etc hosts, remove the erroneous entry, and then give 192.168.0.116, which is my machine 1, 192.168.0.217, that is machine 2, and then save it. And let's check if my machine 2 can ping machine 1 using the host name, and that works perfectly fine. Let's do the same thing from machine 1. So we'll say ping machine 2, and that should also work fine. It would also be good and required that we disable firewall. So we can say UFW, disable the firewall on machine 1, and let's repeat the same on machine 2. So UFW disable, and the firewall should be disabled even in machine 2. So both the machines can ping each other. Both the machines have firewall disabled. Their etc host is updated. And as I said, both machines would not have Java installed. So if we check by giving a command Java minus version or Java hyphen version, it will say Java is not installed, which basically means that we need to have Oracle JDK installed on both the machines, or at least download the JDK package on one machine, which can then be copied across other machine. So we are logged in as root, and let's first quickly start installing some packages. So I'll say apt-get install wget. Now this can be used to download packages from internet, and we will download wget. It's done. Now let's also install OpenSSH server so that we can later have a passwordless access from one machine to other machine using SSH. So I'm installing OpenSSH server. I've already installed wget, and these two packages should be enough to begin with. We also need the Oracle JDK to be downloaded from web. So my OpenSSH setup is almost done here. Now let's repeat these steps quickly on M2. So I'll say apt-get install wget. Now if you get this kind of message, which basically means that some other process is using it, then we can always open a quickly different terminal, and that itself should resolve the issue. So now let's go in here and let's try again. It still doesn't work. Now let me just log in as root, give the password, and then let's try doing this, or we will have to kill the process. Yeah, so it says there is some kind of lock. Now I'm already logged in as root, so I can just say remove from where lib d package / lock, and then let's try doing it again. It still gives a problem. Let's again try doing a installation step, and sometimes you might have this kind of error message where it says it's not able to receive a lock or unlock. So let's go in here, let's check what do we have in where lib d package. There is a lock file, and we will have to remove this. Okay, and now does that work? Yeah. So now it says it could not get a lock on some other file. So let's remove that also, which is cache archives log file, and let's try it again, and it's working. So sometimes we might have such issues and we have to quickly look what is the reason. Might be you can always do a Google and try to fix those issues. So it's trying to connect to archive and basically download the package. We'll come back to this machine. Let's go to machine 1 where we had installed wget and OpenSSH server. We need Java, so let's open up the browser and then let's search for Oracle JDK, and we can go for 1.8 or even 1.9. That doesn't matter. We basically need a Java to be set up on our machines. Now if you look in the usual path, which is user lib, there might not be a directory such as JVM. We can see what is in user lib, and it has various other things but nothing which points to Java. So let's go to our browser and let's type Oracle JDK 1.8. Now that is what I'm interested in setting up on both the machines. Let's look at our machine 2 status. It is still trying to connect, and we might have to give it some time. That's why I was mentioning that we can always go set up one machine perfectly, and once that is done, we can always do a clone, or we can copy or download the packages. Now here I have the package or the link which points me to Oracle JDK 1.8. Let's click on this link. It will ask you to accept the agreement by giving your choices, and this is only for the first time. So I say I accept all cookies, and then it basically shows me the packages here. So let's scroll up, and we have different releases of 8. Now you don't need to go for a very old one, but then it would be good to have a stable one. So I can say accept license agreement, and then since mine is a 64-bit machine, I can go for x64 tar file, and that should download my Java related tar file. Additionally, we also need Hadoop package, so we can open up a different browser and I can straight away say archive archive.apache.org. Although you could also search for Apache releases and you could download. Now this archive page will not only show you Hadoop, but it will show you all different Apache packages which can be downloaded and then we can set up on our machines. So click on Archive of Public Software Releases, and here we will search for Hadoop. Click on Hadoop, and then Hadoop has different components or projects. You can say common or core. So click on common, and here it lists down all the different versions of Hadoop. So let's scroll down and let's pick a stable one. Now you can also download the latest version and set up that, but I would suggest go for a stable one. So let's click on Hadoop 2.6.5, and here we will download the Hadoop related tar file. Again, to repeat, we will need the Hadoop tar file, we will need the Java to be installed on all the nodes. So my Java is getting downloaded, my Hadoop is getting downloaded, and these are the two things which I need to set up my Hadoop cluster. Let's check what is happening in machine 2. So it has already downloaded wget. Now let's also get open SSH server here and let it install, but I will not download my Hadoop and Java here because we have the tar file downloaded on first machine, and once we have a SSH setup, we can always copy the tar files from my machine 1 to machine 2. Let's go back here and let's give it just 1 minute and it will download the packages. Meanwhile, what we can also do is we can go to the terminal and we can give our user, that is HDC, root privileges, so that for any other root related work we don't have to switch to root user every time. So let's click on this terminal and basically add our user to the sudo list. So here let's clear screen. I'm logged in as root, so let's type in vi sudo, hit enter, and here scroll down to the line which says root, and here I can say escape I can say HDC, and I can say my HDC user should have the same privileges as root. Now let's say Control X twice and just save it and enter. So now your user HDC will also have the root privileges and can give a sudo command. Now we have also downloaded our packages in this path. So we have Hadoop, we have Java, and we need to basically unpack them. We basically need to untar them. So both of them have been downloaded. So let's close these browsers. Let's go in here, and first thing what I'll do is I will untar, or I will change my directory to user lib. I will create a directory here called JVM. I will switch to JVM, and then I will say tar xvf home HDC downloads, and then given my JDK package which needs to be untarred here. So this is basically unpacking my JDK tar file, which will create a JDK based directory which will have the binaries for my Java. Once this is done, we should have Java installed on this machine. It's done, and let's see, this is my JDK, and if you look in JDK/bin, these are my Java related programs. So my Java path is user lib jvm JDK. So let's go to this directory and let's copy this path and let's update it in the bash file of root and my dedicated user. So every user has a bash rc file or a bash profile. Now I will update in bash rc export java underscore home. Let's give this path, let's say export path java underscore home / bin. So I can give my Java commands from anywhere, and let's copy this so that we can update the same thing in HDC user. Let's save this and let's refresh this file using a shows bash rc. Okay, now we can test if my Java version shows up for my root user, and that shows 1.8.0. This is done. You can optionally also install Vim, which basically gives you a good layout when you are editing your files in different colors. Some people prefer using Vim when they are editing their files, and I'll show you the difference. Once you have Vim installed, we can always look into the same bash RC, which will show in multiple colors. Remember, we need to update the Java path for our HDC user. So now first let's look at the bash RC file, and look at this. This basically tells you the path which you have set up. Now same thing we'll do for our HDC user. So let's log in as HDC. Let's get into bash RC, and here I will say give your Java path, save it, refresh it, and your Java version should show up even if you're logged in as HDC. So my Java setup is done. Now I also need to untar my Hadoop related directory which we downloaded, and we will do that in a particular location. So let's switch to user local directory. Now you could do that anywhere. I'm doing it here, and I'll say sudo tar xvf home hdc downloads, and then my Hadoop related tar file which I would want to unpack here. And this also shows that my sudo access works fine for my HDC user. This is unpacking my Hadoop tar file in the chosen location. And once this is done, we will have a Hadoop directory created under user local. Let's look, and I have a Hadoop directory which is owned by HDC user, and it will always be good to have our Hadoop path more simple rather than having user local Hadoop 2.6.5. So I will create a link and I will call it Hadoop. So sometimes you have to use the sudo permission because you are in local directory. And then let's change the ownership to HDC for anything which starts with Hadoop. Once this is done, we have our link which is Hadoop pointing to Hadoop 2.6.5, which is also beneficial. If you would want to use a different version of Hadoop, you could always unlink Hadoop and create a link pointing to your newer version. You don't have to then change the Hadoop path in your bash RC every time you work on a different version. So once this is done, let's look into Hadoop, and this basically has a bin directory which has my binaries, or you can say the programs or commands which we will use to work with Hadoop. It has a sbin directory which basically has the startup scripts, and it has etc directory which has Hadoop, and that has my config files. So first let's set the Hadoop path for my user. So I will go to bash RC file again, and here I can add some lines. So I'll say export Hadoop underscore install. So earlier the parameter was Hadoop underscore home, but now it's Hadoop underscore install. We'll say user local Hadoop. Then we will say export path. You can do it in different ways. So let's keep it simple, and let's say Hadoop underscore install slash bin, so that I can give my Hadoop commands from anywhere rather than going to user local Hadoop. And similarly, I'll say export path Hadoop underscore install slash sbin, so that I can even give my startup and stop scripts from anywhere in the machine rather than going to the Hadoop specific path. Once this is done, save it and refresh it. And if all is fine, we should be able to check our Hadoop version by giving a Hadoop command. So we have set up our Java, we have unpacked Hadoop, and we have given the entries in my bash RC. Same things have to be repeated on machine 2, but not yet. Now, first thing what we will do is we will set up a passwordless access across machines so that I can log in from machine 1 to machine 2, or vice versa without a password, which will also be needed when you set up a Hadoop cluster and start your processes across machines. If your SSH setup is done, it will avoid you to give in password of your machines individually. So let's say SSH key gen -t rsa -P, and without a passphrase let's set up a SSH key, which now has created a .ssh directory that has a private and public key. And for our SSH to work fine, we need to have the public key transferred to other machine. Now let's go to M2 and let's generate the SSH key on M2 also. So our SSH server is already installed as we did on my first machine. We will also say apt-get install vim. We also need to make sure that our user here has the root access. So while this is getting done, you can always open up a new terminal. You can log in as root and you can go to vi sudo, and here we will add our user, which is HDC, like what we did on first machine. All control X twice, do a yes and enter. So we have given the user here the privileges to give a sudo command. This is what we did on machine 1. Now this machine is reacting little slow, where it needs to generate or it needs to download a package. Meanwhile, let's open up a terminal and let's do the SSH key part, which doesn't need downloading. And always remember, your SSH keys are user specific. So here SSH key gen -t RSA -P, and it's done. So we can check, even on this machine we have a SSH directory and that has private and public keys. So what we need to do is we need to copy our public key from machine 1 to machine 2 and from machine 2 to machine 1. So here I'll say SSH copy ID -I. I'll give my home directory. I'll say take the RSA public file and let's copy it to SDC M2. Say yes and give your password. So that should have copied your public key, and once you have done that, you can always look in .ssh. Now you have a known underscore host file which has entry of machine 2 where you have copied your public key. If you look on machine 2 in my other terminal, and if I look in .ssh, it has authorized keys. So when you copy your public key from machine 1 to machine 2, in machine 2 we have authorized keys, and in machine 1 we have known underscore host. Now let's repeat the same step here. Let's say home.ssh id underscore rsa dot public, and let's copy it to hdc at m1. Say yes and give the password, and that should have copied your public key to M1. Now if you look in .ssh, this also has known underscore host, and if we look in M1, that will have authorized keys, which basically means your SSH setup should be fine. Let's test by typing in SSH M2, and that should allow me to log into M2 without a password. Let's log out and let's check the same thing from M2 SSH M1, and that works fine. We also need to copy our public keys to the same machine. So I'll say cat from my home directory id underscore rsa dot public, and let's append it to the same location in SSH directory in authorized underscore keys. Once this is done, test a SSH to M2 from M2 itself. Say yes and it works fine. Do a logout and let's do the same thing on M1. So cat home.ssh id underscore rsa dot public. Let's append it in same location in authorized underscore keys. Let's test SSH to itself. Say yes and that's fine. This will also be required when we set up a cluster and we start our processes, that is Hadoop specific processes on the machine. It will not ask for password because you have set up SSH across machines and locally to itself. Now once this is done, we basically have two machines which can not only ping each other, but they can also do a SSH to each other. Let's also check in machine 2 if my installation of Vim is done, and that's also done. Now what we also need is on this machine, that is M2, we basically need the Java package and we need the Hadoop package. So let's copy from machine 1. So I can copy the complete directory, or I can copy the tar file. So I would suggest copying the tar files and then unpacking them so that we can have less data transferred over network. So I can say scp home hdc downloads. Let's take the jdk package and let's copy it to hdc at m2 in the temp directory. So this shows that you don't need to download JDK and Hadoop on all the machines. Just download it on one machine and then copy it across once your SSH is set up. Similarly, we can copy the Hadoop tar file to the other machine also. This is an easier way. In fact, you could write your bash scripts or Ansible scripts to deploy all the packages across the machines. Now let's go to M2, and here we can then first create a directory in user lib and call it as JVM, like what we did on first machine, and then I can change my location to JVM. I can say sudo tar xvf, and then from temp I'll get the JDK package and I'll unpack it here. Once this is done, we need to make sure that our bash RC is updated, or we can even copy that from machine 1 to machine 2. Now this should create a JDK directory here on machine 2 as it did on machine 1, and that's owned by, if there is a problem with ownership, it's good to change the ownership manually to root in case that creates a problem later. Once this is done, we have our JDK. Let's see if everything is fine, and it's fine. Now similarly, I will go to user local directory. I will say sudo tar xvf from temp. Let's unpack the Hadoop in user local location as we did on machine 1. And once this is done, we need to create a link, we need to change the ownership, and we need to update the bash RC. And this is done. Now I can see I have a Hadoop directory. It's owned by HDC. Okay, I can create a link to this, call it as Hadoop. Let's change the ownership to HDC of anything that starts with Hadoop, and we have our Hadoop path also set correctly. Now all I need is from my machine 1, while I'm logged in as HDC, I'll say scp, copy the bash RC from here into HDC M2 in home HDC, which has my Java path, my Hadoop path updated. Let's go here and let's do a source bash RC, and then let's check if my Java version shows up correctly. That's fine. Let's check if Hadoop version shows up correctly, and that's fine. So now we have two machines which have Java, which have Hadoop package, which can ping each other, which have SSH access, and which have firewall disabled. These two machines can then be used to set up my Hadoop cluster once we start editing the config files, and that config files can be found in user local Hadoop etc Hadoop in both the machines. User local Hadoop etc Hadoop. This is where we will edit our config files, and then we are ready to bring up our cluster, which will be a 2-node cluster for my Hadoop. My strategy would be on M1 machine, I would have a name node, I would have a data node, I would have a resource manager, and I would have a node manager running. On my M2 machine, I would have a data node, I would have a node manager, and I would have a secondary name node running. So this is the plan for cluster setup on these two machines. To set up our Hadoop cluster, we will need the config files, and I have updated my config files in GitHub link. So let's go to GitHub. You can always refer to this Git link which I'm showing on the screen, where I have the config files updated, and we can just easily copy our config files from here. So let's click on this link, and here I have given the config files. So we can click on Hadoop 2.6.5, and this basically has my 5 important config files which we need to update in both the machines. Now let's go to machine 1, and here let's go to user local Hadoop etc Hadoop, and here the first config file which I will update is core-site file. Let's get into this, which has nothing as configuration specified. Now, as I mentioned when I was explaining HDFS, that in Apache Hadoop we would have to download the Hadoop related package, we will have to edit the configs, we would have to do the formatting, and then we would have to start the cluster. However, if it was Cloudera or Hortonworks or any other vendor specific distribution, downloading the packages, editing the config files, formatting the cluster would be taken care by your installer. Now here let's go to the git link and let's get the contents of core-site file, which basically tells the HDFS path, the location where my name node would run, and the port to which my name node will listen to. So let's click on core-site file and get the config files or the properties, scroll down, and we just need to give this, although there can be many other properties which can be specified, but we will just go for a simple setup. Copy this, come to your terminal, and here I can just paste it. Now this tells the property is fs.defaultfs, which is also used if developers are coding their file system API and would want to connect to HDFS. Now here I will change my machine name M1, and this is the machine where my name node will run, and it will use 9000 port, HDFS://M1 9000. Let's save this, and our first config file is edited. Now the next file which we would want to edit is mapred-site file, and what we can do here is my mapred file shows up as template, so I'll just rename it as mapred-site.xml, and then let's edit it, which tells what processing framework we would be using or what processing layer we will be using. Let's go to the git link again and let's pick up the information of mapred-site file, which is here, and the processing layer which we will be using is yarn. So let's copy this. Again, there can be many more properties specifying your values of memory for map and reduce and many other properties. We will just go for a basic setup, which is more than enough even to test out all the functionalities of Hadoop cluster. So my processing framework will be yarn. Let's save this, and we have edited the second file. Similarly, we will also edit my third file, which is HDFS-site file. So let's go into this, which basically tells what will be my replication factor, where will my name node store metadata on disk, if I plan to run a data node here, where will data node store the blocks, and so on. So let's go to HDFS-site file. Let's give the properties. So let's go in here and let's get the content of HDFS-site file. Scroll down and let's get all these values, that is replication, the path of metadata on disk, the path where my data blocks will get stored, what is the HTTP port my name node will use, what is the HTTP port my secondary name node will use, and my secondary name node's checkpointing frequency, which is by default 1 hour, but we will be setting it up as 10 minutes. Let's copy this, and here I will paste it. Now let's make some changes here quickly. So I plan to run 2 data nodes, so I can go for a replication of at least 2. Since I'm planning to run 2 data nodes, I have given a metadata path, that this is the path where my name node will store metadata on disk. Metadata on RAM is dynamically built. Metadata on disk needs a path. That's why we are giving this, as we plan to run name node here. We also plan to run a data node here, and we will give the path for my data node to store its blocks. Now remember, since we are in Apache Hadoop cluster, we will have to create this ABC directory. The name and data directory will get automatically created. Now this also tells what HTTP port my name node will use, and here I will specify my name node would run on M1 and it will use an HTTP port 570. For my secondary name node, I would want it to run on my other machine. So I'll specify M2 and it will use 590 port. Now, since I'm planning to run my secondary name node on my second machine, I don't need to give this property here. I'll give this property in my M2 machine's HDFS file. So let's delete this and our HDFS is set up. The next file which we need to edit is yarn-site file, which tells about your resource manager, your resource tracker, and some other properties. So let's go into yarn-site file and let's get the values from here, which if you scroll down, you should be able to find, and scroll down and you have these four properties. Now there can be many other properties, as I said, like specifying how much memory you want to allocate for node manager, or how many CPU cores, or do you want to enable or disable physical or virtual memory check, or do you want to enable log aggregation. So you can copy all these properties from yarn-site file and let's place it in my machine. Now these are all my properties. Let's carefully check if everything is fine. My resource manager is intended to run on M1. If you want to run it on some other machine, then you would have to give the host name of that machine. My resource tracker, which helps your resource manager to know about resources, will also run on M1 but on a different port. I have some shuffle classes which are relevant. Now this property tells how much amount of memory you would want to allocate for your node manager on this machine. Now either we could keep it minimum or we could let yarn decide it for us. So let me get rid of this and the CPU cores. So the default memory and the default core which yarn will assume for your machines, for your node managers, would be 8 GB and 8 cores. Rest properties can be left as they are. You don't need to make any changes. Save them and your yarn is also done. Now we will edit a slaves file which tells on which machines will my data nodes run and hence my node managers run. So I'll say M1 and M2. So my 5 main files are edited, which is core site, MapRed site, HDFS, yarn, and slaves. Now you can also edit Hadoop environment and yarn environment, but that's not mandatory, which mentions about your Java path, which mentions the heap size, that is the amount of RAM which will be used when your process comes up. The default value is 1 GB and you don't need to make changes. So let it be as it is. I don't make any changes to Hadoop environment. Now once these config files are edited, let's quickly copy them across M2 and then we can edit them in M2. I'll say scp, take the core file and let's copy it to sdc M2 in user local Hadoop etc Hadoop. That's the path. Done. Let's copy the other files also, which is my MapRed file. So MapRed file, let's copy this. Let's copy the yarn file, slaves file, and HDFS file. So that's my yarn file. Let's copy the HDFS file and let's copy the slaves file. So all my files are copied or should have been copied by now to my M2 machine, and then we can accordingly update the things in M2. And I don't need to really switch to M2. I can just say SSH M2 because I can log in from here. I can go into user local Hadoop etc Hadoop, and now we can look in the core file, which doesn't need any changes because this tells what would be your HDFS path and where your name node runs, and this would be same because we would have data nodes running on every machine talking to the name node, so they need to know where your name node is running on what port. So we don't make any changes to the core file. MapRed file doesn't need any change, so here we have the framework as yarn. Also, what you can do is to make sure, remove if there is any template file. Let's look into HDFS file, and this will have some changes. So replication, no, that doesn't need a change. Do we need a path which tells where metadata is stored? No, because our name node does not run on this machine. Do we need a path for data node? Yes. And let's give just a naming convention. Let's add a number 2 here, which tells me that this is second data node. HTTP port is fine. Secondary name nodes port is fine. And then we can give the checkpoint period property, which tells how frequently should my secondary name node do the checkpointing. Now, as I said, the default time frame is 1 hour, but then we can set it to a lower time frame by giving a property that is in my HDFS file, which we had deleted from machine 1, but we will retain it in machine 2. This is the property which tells what is the frequency of checkpointing that secondary name node should follow. So let's give it here. And this says every 10 minutes I would want my secondary name node to do a checkpointing and have a copy of metadata of name node that name node stores on the disk. Now I am not specifying a path where secondary name node should keep a copy of name node's metadata on disk, and by default my secondary name node will store it in temp, and that's fine for now. So let's save this. Now let's also look in yarn file if we need any change, which tells resource manager will run on M1, that's fine. Resource tracker will run on M1, that's fine. Shuffle classes, some other properties which tell don't check for physical and virtual memory, and log aggregation. So we really don't make any change to our yarn file. And our slaves file, which tells where my data nodes will run, that means where my data nodes and node managers will run, we don't make any changes. So all my config files are edited on M1 and on M2. Now don't forget to create the directory which you have mentioned in the config files, that is ABC, and make sure that our HDC user has the permissions to this, or you might have some failures. So I'll say ABC, that's done. Let's do the same thing on M1, and let's change the ownership of this directory. Now once all these steps are done, both the machines are set up to basically have a Hadoop cluster running. But that cannot happen without we doing a formatting. Formatting is the first step which will create the initial metadata in the metadata path. So as of now we have nothing in ABC directory. So we will do a formatting of HDFS, which basically prepares the HDFS to store the data. So I'll say HDFS name node format, and this has to be given only once because this creates the initial metadata in the name node's path, which we have mentioned in HDFS file. Once the formatting is done, no matter how many times you restart your machines, you will never do a formatting again, because if you do a formatting again, it will bring your cluster to the initial state. Let's do a formatting which should create my initial metadata in the ABC directory, and that would also create a /name directory as we have specified in our config files. Once this is done, have a look at your ABC directory, and that has name. Name has current, and in current you have the initial FS image, which is the file system image, which tells as of 23/27 your machine has this. Now once this is done, we can also look into ABC/name/current, and here we can look into the version file which has the initial identifiers, that is your namespace ID, cluster ID, and block pool ID. And this was the reason I mentioned that you should never ever do a formatting again, because reformatting will change these identifiers and set them to new ones. However, your data nodes, which will also have a copy of these, might not get updated. Now once your formatting is done, once your initial metadata is created, we can just say start-all.sh, and this script internally will run two scripts. This script internally triggers start dfs.sh and start yarn.sh, and internally these scripts actually run Hadoop daemon.sh start, and then your process name such as name node or data node or secondary name node, and yarn daemon.sh start resource manager and node managers. For more information, you can always refer to the sbin directory, which talks about these scripts or which shows these scripts, which you can check in user local Hadoop sbin, which has the individual or startup scripts. So now let's click on start all.sh, and if everything is fine, it should basically start your cluster. Now it says this script is deprecated, use start DFS and start yarn, but it will still work. Now since we have set up SSH access, it does not ask or prompt for a password. It starts your name node, it starts your data nodes, and then it will basically start your secondary name node and resource manager, finally your node managers. So we will have a 2-node cluster now, which uses 2 machines which we set up, that is M1 and M2. It has one single name node, it has 2 data nodes, one secondary name node, and it will have one resource manager, which is the master of processing layer, and then 2 node managers, which are the processing slaves. We can always check the processes using jps command for Java related processes, and we can check on other machine for my processes, and we have a 2-node cluster up and running, which has 2 data nodes, 2 node managers, 1 name node, 1 resource manager, and 1 secondary name node. We can also look into the ABC directory on M2, which will now have a directory for data node, and that will have a version file which can be looked into for identifiers, and you can always look into a different version file, which is here. So you have 2 version files, and both of these version file have the identifiers which they have received from the name node. Where will my blocks get stored? It will be stored in current finalized, and then it will be within this path if we write data to HDFS, where my blocks will come and get stored. Let's check the same thing on machine 2, which only had a name directory in ABC, which now also has a data directory, and similarly it has the version file at under current directory or a version file which is under the block pool directory. So this is my 2-node cluster. We can quickly give a command, that is HDFS DFS admin report, or you can always check what are the options in HDFS by typing in HDFS, and here you have an option called DFS admin. Again, you can check for all the different options with DFS admin, and here on the top we will have an option called report. So these are all the commands used by an admin. So you have report, live, dead, or decommissioning. So we can check how many nodes we have by typing in HDFS DFS admin report, which should show me that I have 2 data nodes. How much of those nodes is configured for distributed file system, how much is for local machine, are they responding to name node by looking at the last contact time, which will get updated every 3 seconds, and you have machine 1 and machine 2, which are 2 nodes or 2 live data nodes of your Hadoop cluster. This is via a command. We can always go and use the browser and look at the web UI. So I can check M1 using its HTTP port to have a look at my name node, which tells me what is my cluster ID, what is my block pool ID, the configured capacity, how many live nodes we have, is there a situation of under replicated blocks, and it tells me that there are no dead nodes. You can click on live nodes, and that gives you your 2 data nodes, what is their capacity, how much is being used, how many blocks does that have, is there any situation of failed volumes, and you can look for more information. You can always look in here and you can say browse the file system or look at logs, which you can also find from your machine in your Hadoop directory, but you can click on browse the file system. As of now we don't have any data, and this is the web UI for your HDFS for your name node. However, this does not allow you to work with HDFS. It only allows you to browse through HDFS and your Hadoop cluster. You also have a UI for Resource Manager, and that should be accessible using the default port, which is for Resource Manager. And as I mentioned, since we did not configure the amount of memory and CPU cores which is allocated to every node manager on every node, it will go for default memory settings, that is 8 GB, and default cores, which will be 8 cores per node. All of those settings can be changed, but then to begin with, you can have a simple cluster with 2 node, which says there is 16 GB memory available, although that's not true. You have 16 V cores, but then we have 2 nodes where we have data nodes running and we have node managers running, which will be used for processing our data on this Hadoop cluster. So this is a simple 2 node Apache cluster, which can then be used to write data, process it, and store data in a distributed fashion. So thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.